Today we're going to be having a panel. Here are our panelists today. The bios were made available to you at registration and also through your confirmation materials. So I won't go through those today, but I wanted to just tell you a little bit about how we're going to moderate today's panel. Each of the panelists are going to have an opportunity to come up. They have 5 minutes of opening remarks where they're going to talk a little bit about our topic today, which is demonstrating a business case for artificial intelligence. At the completion of those opening remarks, we're going to be using the questions that you submitted, and thank you for all of you that submitted questions. You made my job so easy. We'll be submitting those questions to the panelists and giving them a chance to really expand on the things that were most important to you. So that's how we'll be conducting today's panel. Are we ready to get started?
Sure.
Okay, great. And then this.
We're also the panel that gets to follow Jensen's keynote this morning, so this is going to be a tough one to follow. So good afternoon. My name is Troy Marr. I'm Architecture Manager for Data Analytics and Insights team at Rockwell Automation. Rockwell is the world's largest company dedicated to industrial automation and information. We've been talking about the connected enterprise for the last couple of years. It deals with concepts such as leveraging the power of data to connect the shop floor with the executive suite. In my area, we're blending a lot of these concepts, corporate analytical data, cloud computing, edge analytics, and IoT to showcase how to pilot and productionize specific use cases. What I want to highlight today is how we deal with Rockwell's 4 electronics assembly manufacturing plants producing printed circuit boards on 23 service mount technology lines. These are high volume operations, with each plant generating approximately 3 billion data points per year from 250,000 chip placements per hour. It starts with a bare panel that has solder paste applied to it. Chips are then picked from reels by vacuum nozzles. Each service mount machine has approximately 400 nozzles performing this operation. Problems come from improper solder application and nozzle misalignment or clogging. Oftentimes, problems are only found at the very end at electrical test. This can lead to product waste, quality issues, returns, and possibly customer dissatisfaction. The goal is to use machine learning to identify patterns that predict failures before they appear, as early in the process as possible. The first use case is solder paste inspection. We've targeted difficult to troubleshoot and repair hidden solder joint failures, which are typically discovered downstream at the end of the assembly process at the electrical test station. We trained a supervised machine learning model using historical parametric solder paste inspection data. The model is approximately 90% effective at predicting electrical test failure. This enables us to provide near real-time feedback to line operators and allows notification to pull the board and wash the solder paste off prior to any further work, recycling the board for reuse. Benefits include higher defect detection rate, reduced errors and waste, improved quality control. The diagram shows the technical architecture, including edge analytics, like Jensen referred to this morning, and cloud model training. The second use case is our pick-and-place process, where we have machines that attempt to self-correct any alignment issues, and alerts typically occur when the machine goes out of alignment, where it reaches a point where it cannot correct itself. This is essentially an alert where production has already been impacted or we have an outage. The desired state, however, is where you have actionable insight. We created a first generation where an alert's based on business logic that notifies the operator when the process has started to go out of control. We've then created a second generation now where we have machine learning in place to identify patterns to predict failures before they appear as early as possible in the process. The diagram shows the technical architecture where we have edge analytics, cloud components, and mobile notification for operator action. This is based on hierarchical temporal memory with unsupervised learning. So the solution we put in place is based on the business case tied with requirements to value. Reduced downtime, product waste, product returns, with improved quality and line efficiency. To do this, we explored options. We looked at the data, We understood it, wrangled it, looked at options to improve the data flow. We then evaluated and selected technology, looking at device level and edge analytics. We looked at the technical stack that we could deploy, including how we looked at the edge all the way up through the cloud, including the management plane, what level of data we needed to retain. And then finally, how do we make it actionable, including business value for mobile alerts. Finally, we deployed it and refined it. We went through multiple generations. In closing, research shows that AI/ML is most often deployed to automate repetitive or manual tasks, augmenting complex tasks, improving customer experience, or reducing costs. The two use cases today are a case in point, eliminating waste. Going forward, we see that research expects to focus on new revenue, not just on items impacting the bottom line. We already have a number of business units actively looking into this, sometimes based on new machine learning capabilities built into our basic enterprise analytic capabilities. Technology is keeping pace. The data is there. Now it's a matter of what we do with it. Thank you.
Thank you. My name is Saad Sirui. I lead the Advanced Application and Digital Business Component, CT business at GE Healthcare. I'm here representing GE Healthcare, which is an honor for me. GE Healthcare, of course, is a company that produces everything from a diagnostic imaging test from an MRI machine all the way down to monitoring systems. And what I'm going to be talking about here is really looking at how, when we look at deep learning and AI, how is that going to impact our business, and how is it going to provide value to our customers? And when we look at the entire spectrum of where our diagnostic imaging equipment can actually have a benefit to our customers, it's the whole spectrum. If you look at a patient's journey through the diagnostic realm, it's from order entry all the way to the final report that is generated. And so it's all about, and this is a fusion of these different data components that are being generated, whether it's the information in the medical history record that would trigger what type of exam or a protocol that should be done, whether it's the imaging information that would be needed to make sure that the patient is properly positioned in a scanner, whether it's how do we actually create the correct scan acquisition protocols when the patient, for that particular patient, for that particular purpose that they're coming in, and then start the scanning. From that point on, also it is for the purpose that the patient is in, what is the optimal exam, or what's the optimal image that can be reconstructed. And then, of course, after the images have been reconstructed and presented to the physician, can we add more value to those images than just presenting simple images? So how do we add information to those images? And that's where the automated or automatic analysis of anomalies or of automation in the labeling can also start coming in. So this is the spectrum that GE Healthcare works in, and when we look at this amount of data that is being generated, this is really at every single aspect we can see that there is opportunity on how we can actually leverage different components of this data through the deep learning chain to start having an impact and start producing applications and products that can benefit our customers and their patients. And this really goes towards how do we deliver value to the end patient in precision healthcare. So how do we start looking at that individual as an individual rather than an average of people? And as an example of that would be a patient coming in with a different heart rate or a cardiac output or a blood pressure may need to have a different type of an exam done at a different rate than one that would be at a different rate. So how do we incorporate that information so that when we do the exam, that it's the most optimal exam? And then, of course, at the efficiency level of a hospital, to be able to correctly identify which patient needs to go to which scanner for what purpose. And so those are areas where we feel that the deep learning technology can really have a huge impact in how we provide value to our customers. A couple of examples that I will share of how we've actually used these and incorporated them. So last year we introduced the world's the first deep learning image reconstruction algorithm, in which the target was how do we address noise in an image without impacting any of the image quality. And we successfully introduced that product. It's called True Fidelity. And this really has a benefit of reducing dose to the patient. And I think Jensen, for those of you who were here before when Jensen was talking, that's one of the things that we mentioned. Another example is really about the post-imaging aspect of it. So how to use deep learning to actually automatically identify and label spine segments in an image. And very recently, about yesterday almost, we introduced our first X-ray AI product for the critical care suite that automatically detects pneumothorax in an X-ray image. Now, doing this, we've actually introduced a whole platform that really drives us to go to this level. And this is really how we collect the data. The data has to be in the right form. It's the data that's going to drive the language it's the data that's going to be responsible for producing the models. And for us, we've named this the Edison platform, and this is really going to drive how we move into this new age with incorporating deep learning in every aspect of what we're looking at. That's for me. Thank you.
Well, good afternoon. My name is Glenn Fong, and I'm the Director of Machine Learning Research at American Family Insurance. A little bit of my background, just quickly, is I've been a machine learning practitioner since the time that machine learning was a curiosity for academics. So I got my PhD in machine learning in 2003, and I've been in the industry doing machine learning since then. So, and I had the opportunity to come to Wisconsin and start a group of machine learning researchers that's very focused, hardcore machine learning. And so right now we are about 12, and it gets bigger in the summer. We have interns. And my mission in American Family has been try to convince and to share what these technologies can do for the business, right? So more specifically, my team does two things in there. So one is to always exploring the new technologies that are coming up, because this field is moving so fast, right? That papers, for example, technologies that we are using today, the paper came out 6 months ago. And for example, for natural language processing, the models evolve so fast that there are models beating state-of-the-art numbers literally every couple of months. So my team, it tries to keep up with that, which is not an easy thing to do nowadays. And number two, I also lead external relationships. So we have relations with universities like yours, and we try to engage with professors and do exploration that is not only interesting for the business in our point of side, but it's also interesting in the machine learning point of view, so we can get a good synergy between the collaboration. We have a big one with the University of Wisconsin right now, where we study in a center that is the UW AmFam Data Science Institute for research, and I lead that relationship with the UW. So for me, being in this field, I feel very lucky. So it's moving very fast, and again, It changed from being something very academic to being something that we see in our everyday lives, as you saw in the talk from the keynote speaker. So moving on. I just want to be brief. So I just wanted to talk about one use case that we're very excited about this. We're very excited in my group and I. So the motivation is a very simple one, information retrieval. So we have, so insurance, I've been in several fields because again, so I feel like I'm a machine learning practitioner. I work in healthcare in Siemens for many years, and then I went to Amazon and did retail, electronic e-commerce, and now I'm in insurance. But I feel like the insurance domain is one of the hardest ones because there are rules. This is complicated. The products are not simple. They change by state, so it's very complicated. And finding information about those is a must. So you should be able to retrieve information quick and fast. So one of the motivations here is the agents always have questions about products that they want to offer or things, or coverages or eligibilities, right? And traditional systems of information like web retrieval or search by keywords sometimes doesn't work. So it works sometimes, most of the time, but sometimes it doesn't work. And that ended up being a lot of extra burden in call centers, because if you don't find the answer, you call a call center and say, hey, can you ask, tell me the answer to this question? And that's a lot of time, and time is a lot of money in our call centers, right? So a couple of metrics there. So a percentage, it's not a big percentage, but it's a significant one. Searches don't return the desired information, and again, so it's a lot of calls that go to the call centers. So in order to solve this, the process was, so we had to understand exactly what the problem was and talk to the users. And in our conversations, we framed this not only for the specific problem of finding things in these manuals, but also as a whole, we can see this as a holistic solution for information retrieval and for knowledge management inside the enterprise. And we guided I'm not going into the technical details, but this is one more like our guidance principle. We wanted to have, everybody wanted one place to find all the information that you need. We have one truth. If we have something that can model the knowledge that we have in the company, it can be used for not only finding searches, but also for a chatbot, for example. Chatbot can query this knowledge if it's in a general way and can answer people. The systems. So if we can have all the knowledge in one place, the policy centers can also query that representation of knowledge. So when you change this knowledge in one place, can update everything, so you don't have to have all that expensive coordination between different places where that information is needed. Context, so importance, why are you asking something, in what context you are. And this is most of the part when the machine learning comes in. You have to understand what people is asking. And not only when they're typing it or asking in natural language understanding and processing, but also in different interfaces. Like if you are talking, it would be great to have an agent that is listening to the calls and a kind of an AI agent and tries to suggest search even before you type them in, right? So again, because we only have 5 minutes, and I think I'm probably almost got all of them, I just want to quickly tell you what the problem is, right? So if somebody wants to find what is the maximum age for the good student discount, they do the search, and then because the search is not customized to ask questions as a human asker, you don't find any answer, so they have to type it again in a different way, and then finally they find a way that retrieves some results, and they have a link, so they click in that link, and then it takes them to the page when the information is, and then they have to read everything to trying to find the result that is 25 over there. So what we're proposing is a system where you ask the question, what is and we already did it, so it's going into production. We have a team of 30 people looking for it, testing it right now, and getting user feedback on to improve the interface and all that. So they just type a question, and the system, we train a system in Wikipedia pages. So Stanford released a data set that has questions and answers and the context. So we train this AI system that understands the semantics of questions and automatically goes and retrieves the answer for you. So again, and not only do that, but it tells you where it found it automatically. So the information retrieval is painless and is automatic. So thank you. Yes.
Most of my insurance is with American Family, so now I know where to go. So this is exciting. Thank you so much for all your comments. I think like some of the things that we heard is certainly that there is a use case as it pertains to reducing any kind of errors, reducing costs, making things easier for the customer. Did I miss any like key things? Is there another use case that your company is looking at? And I'll just start with Glenn. Anything that your company is looking at that you didn't talk about today in terms of just the primary benefit to the
Yeah,
company?
from, you say in general, from AI?
Yeah,
Oh,
just
we
in
have
general.
many, many applications that I've been working on, and some of them are more into production already, but some of them are very exploratory, and we are, training all these models. For example, insurance is a classical place for doing analytics. So since the beginning, we use models to assess risk and all that. So on top of all that, customer interactions are very important, and this is one example of that, where we are interacting with not only with the customers, but with the agents in order to make processes more efficient, but also using all these technologies that take voice transcription and can also examine thousands of calls and bring to the managers the calls that we think need more attention to it. That's another use case. So we have using computer vision in order to assess damage in roof. So nowadays somebody has to get into ladder and go up in a roof, and it takes a lot of time. So when a storm hits a neighborhood, you need resources to go and explore that. So we're now using drones that you can put in the ground and goes over there and examine all the damage and automatically can suggest it is damage. And the applications are, especially in insurance, are many.
Thank you. Troy, can you talk a little bit about what data was used to justify the business case for your project? Because I know that Rockwell's doing quite a bit, but what data did you use to be able to say that it was going to provide a benefit for the company?
Sure. So for this specific use case, which was a production-oriented, we looked at waste, we looked at, obviously the production costs that went into it, but a lot of it came down to, production costs. So what was the impact of a line outage? That was really what drove to it. And then ultimately, what was the impact of potentially shipping bad product? So a lot of it went to the true financials of it, but also, in the end, it came down to what was the impact of a line being down for a certain amount of time. That was really, foundational to that business case.
Saad, I want to ask you the same question because you're a totally different industry. So what was the data that you used to justify the expense of looking into AI?
I think it was really about what's the additional benefit that we can actually produce and reduce the amount of inventions that need to happen through human resources. So for instance, the examples that I was talking about, deep learning image reconstruction, we have done to the traditional machine learning computer, and what Jensen was basically talking about, the complexities of writing a code. I think we've converted that complexity into the model being learning, and it was basically showing the case and having the management agree to it and move fast to actually prove that it could be done. So those were the real components of how do we reduce the cost of the development and the speed to market.
And then in terms of that specific case, for the first project that you took on, what was the overall length of that project? And then did it meet your expectations or did it not meet your expectations?
That project, yes, it met, and I think it exceeded the expectations. Even from our customers' feedback that was there was exceeded the expectation. It was literally from start to end, it was within a year.
And that's what allowed you to then move on and take on additional projects.
Yes,
after
and I
that.
think it was the litmus of how do we move fast, and also this allows us to fail fast as well.
Correct. One of the things that, this is another audience question, is what excites you the most about the power of AI and ML and its potential impact? So I was hoping that maybe you could each briefly answer that. What is the thing, today when we listened to Jensen, it was about visioning, despite all of the things that might be barriers. So there, he's visioning about what the future is. He was asked about what's next. And I think that when he said what was next in his mind, people laughed, but he was just being honest. So like when you think about, now that you know the technology, what excites you the most and about the potential that it can have? Maybe if you could start first, Glenn.
Well, for me, again, is the speed. I feel lucky to be in this in this field right now, and I interact with many professors, and I ask them, how do you keep up? Like every time, every month there is a relevant paper that comes out, and it's hard for everyone. At the same time, that is exciting, for those guys have to get new ideas and put it out there, and you don't do it super quick, so there's a lot of pressure for PhD students. But in the frame of that, the technology now is giving a lot of results, and I've been in the field for a long time, and it has not always been the case. I think we have the right infrastructure and the necessary data to take advantage of these models. And I think that's what is exciting for me, is that I see a lot of adoption, and I think we're just starting riding that wave. And that's just going to get bigger and bigger. And more concretely, just quickly, how we are making really good strides into teaching machines to understand language, human language. Is amazing the way it's doing. It's like, I have a presentation that where I show people when we build these models customized for insurance, and we play kind of Mad Libs with the models. So we put a phrase and we want the models to complete. And if we use, for example, models trained by Google, they are great, but they don't know insurance. So they say that the customer called because, and they say, oh, they wanted to exchange the toy. And that doesn't make any sense for us. But if I put my model, it will complete, and it will say the model called because they need a rental car because they had an accident. And those are the kind of things that are even impressive for us as a practitioner. We see, and when with these models are ready and we test them, ourselves get surprised ourselves. So that's very exciting for me.
How about you, Troy?
I'm in what's considered corporate IT, and we're now at the point where we've got both the data sets, but more importantly, the tools with AI that will put the power in the hands of the business users. And I think that's really where we're at the cusp of really giving them what they've been asking for a number of years. And I think that's what's really exciting.
So I think for the excitement for me is really when we look at the entire spectrum of where AI can start having an impact, it's then fusing all of that information together, right? And really like all the sensors and everything, and this can literally change the way that healthcare can be delivered to our customers at a personal level. So it's not at a standardized set of healthcare for everybody, but it's personal healthcare to an individual. And I think this is where, this is where AI can really start making it happen, fusion of different resources and all the data coming together.
I think in a lot of the interactions that I have with companies, there's a lot of conversation about wanting to get started and how we get started, and looking to faculty and looking to consultants and looking to others just to be able to say, how am I going to make use of this technology? But I don't know in some of those conversations that they've identified that vision for what they're trying necessarily to achieve in a way where it's something that they're passionate about. I heard that a lot from Jensen this morning. I hear that from all of the things that you've already described. It's really about making a change that will last a long time and to actually transform your industry and the way in which your customers interact with you. So I think that's really exciting. One of the things I wanted to turn to just briefly is, based on your experience with these implementations, how might AI disrupt the technology market? So one of the other points of confusion for a lot of companies we deal with is just the plethora of options. There's a plethora of consultants, they don't know who to go to. There's a plethora of tools, infrastructures, architectures, and it's a little bit overwhelming. How do you see AI disrupting the technology market?
I'm going to go first.
Yep.
So I actually see a trend on companies building teams to do their own AI. That is, again, it makes a lot of sense to have knowledge in-house and customize the algorithms for the needs that we have in our companies. And the way that's like the first step of and that will disrupt the market, because I think they need things that have to come out from outside for vendors has to be really, really interesting and good in order to be worth, having incorporating those technologies instead of experimenting to building it in-house. And what I've seen is that's the first step. The second step is like it happened in Amazon. So they form all these machine learning groups that were like internal consultants. But the evolution is that every business unit ended up having their own machine learning team. And that's because you not only need the machine learning and the AI expertise, but you need the business expertise. And that is very hard to get from consultants. So you really need to know what you need to do for your specific use cases, right? So I think the evolution is that every main business units in big companies are going to have their own machine learning team inside there.
So start small, have a defined scope. In the two use cases I showed, which was still based on one assembly line, we actually pulled in the business domain expertise with our advanced manufacturing engineering group, and that's what made it successful. But it was still a small group, small defined scope, and don't fear failing fast. You really need to be able to call it if it doesn't work, and have iterations. Go through that defined set of scope, call it successful, call it a failure if you need to, and then get to your next iteration. And recognize that what you're doing now will be different 18 or 9 months, 10 months from now. And then recognize that something's going to change, the technology or the business requirement. Okay?
Hassan?
I actually echo the sentiment that it's you really need the subject matter expert to be embedded with the new deep learning skill sets. It should be used as a tool to further what the business plan is for the business. And I also agree that you need to show quick response and really fail fast. This is one of those opportunities in which you can accelerate the growth by just learning where you can fail fast. The other key component of this is that I mentioned before also, but the data and the right type of data is going to be the key thing. So thinking has to start shifting from when we're talking about what we need to do in a development, it needs to start thinking by what algorithms I need to, what is the right data and what's the right type of information that's going to be needed to train those models, and how do we go back. So we'll shift from one set of expertise to another set of expertise in data curation and stuff.
Saad, I want to follow up on that a little bit. When you got started and you needed to start pulling together these interdisciplinary teams, what did you have to do to upskill your teams to be able to do this well? So two components. One was we really needed to inject some data scientists with deep learning expertise. So we had to inject that. So we added some data scientists in that role, but having data scientists in like a silo would not help, because they didn't know what was the problem that we needed to address. So they needed to work together with the expertise. So that's the way that we've built it, and we've growing that expertise within the organization by just making sure that it's not working in a silo all on their own, but they're actually embedded with the expertise in the business. So Glenn, one of the questions I would ask too is, now we're here at a higher education institution, and I know you work with universities, you mentioned in your opening remarks. What, for all the faculty and administrators and executive leadership at universities, what would you say needs to change in order for graduates to be better prepared for the future of work?
I think I'm a big proponent of academic collaborations with industry. I think that's the way, because then the process of assimilating talent that comes from institutions like yours and come to work in these machine learning teams is not a disruptive process. It's just a continuous process that starts with internships, summer internships, projects with the professors, and then in the same way we learn, so the companies learn from the experts what are the things that are out there, and then what are the students are learning, and the same way the professor learns what are the needs of the industry in order to provide a better education and prepare the students for joining the workforce later on in their career.
And Troy, for any technologists that are in the room, if you had one piece of advice, they have an opportunity to upskill their own talents, start learning things. What would be the one thing that they could start doing to make themselves more valuable to the employers that they serve?
Recognize there's a business requirement to it as well. So it's not just about the technology. Learn the business.
Learn the business side.
Yeah.
Very good. As you go forward, if you had one thing that you'd like to be able to see your company advance with AI and ML that is not being looked at today, but if you just had your vision of what you would like your company to be looking at in the future, what would that be? Saad, I'd like to start with you.
That's an interesting. I think the area where it's it's the speed. It's the risk and speed and the ability to actually just go in and start doing things much faster. I think that's traditionally we've been extremely risk averse. And that's the one area where I feel that that's an area that we can leverage deep learning and data analytics to push us through that barrier to start taking more risks, but to get to a solution faster. That would be one of my areas.
Troy?
Not to repeat that, but looking at the top-line opportunities as well, revenue.
For me, there is two main things. So one is this process of assimilating and thinking machine learning-like is not only for scientists and data scientists, it's for the whole company, I think. So things are happening. I used to tell, when I joined American Family, I used to tell people in Amazon, I got managers coming all the time to my team and telling me, hey, I have a machine learning problem for you. And for me, that's the best case scenario, where people start thinking about what this technology can do for you, because you are the expert, you have the problem. So you can bridge that, you can go a step further, bridging the bridge between the gap between the technology and the business case. That will help a lot. So educating and getting people to think what this technology can do for you is number one. And number two, and that's happening in my company. I wish we get there faster, but it's happening. Number two is being able to deploy models faster and easier. And I think that's a problem for every company that I know out there. I don't know any company that says, oh, this is super easy for us. So there's a lot of complications of getting the data. There are privacy concerns. There are ownership of the data is always difficult, security, and being able to get from the prototypes that the machine learning teams build to production is always not as easy as it should be. And I think getting there for me is paramount. It's very important.
I think that was one of the questions that came from the audience. I think this came from a student, was just to ask, how is managing a project, a non-AI project, different than an AI project? And I know a lot of companies have moved to agile software deployment, and they're moving more quickly. They're doing things on sprints. Why is AI different? Saad? Is it different?
I mean, like, as far as what's the input and output, so what's the requirements for the project or the product to be successful, that remains the same. Mm-hmm. I don't see anything different between injecting AI. It's basically, like I said, it's replacing some of the complexities that we had to do normally with some other skill set. So at the end, it doesn't change how you manage the project. The expectation is this project would go faster.
Mm-hmm.
It aligns to agile methodologies very well. Yeah.
Glenn?
Yeah, I agree. It has many similarities. It's one difference, I think, is the dependency on data. I think that makes them a little bit different. And again, so when you spend time building these models, a lot of the time, people say 80%, I don't know if that's the right number, but to get the data together. And not only getting it together to build your model, but also to being able to make that data available to the model when it needs it, right? So all that data pipeline makes it a little bit different from other projects, right? That you need this constant data, and then you need what to do with the outputs of your model. And again, the whole infrastructure, we draw a big ball about a project related to machine learning, where machine learning is the core. The machine learning part is like a really small ball in the middle of all this that wraps it up, right? So, so again, like 90% is similar, but it has this really tricky component that goes in the middle, and that is kind of different. Yeah.
Data wrangling is really important.
Yeah.
There was one question that asked specifically, can we move forward, and I know this is probably more on that small to medium-sized companies, are we able to move forward with AI if we don't have a data scientist on staff? What would be your answer? Glenn?
I would say no.
Yeah.
For me, it's a
It
no.
would be hard.
Yeah, there's many platforms that promote one button push and put the data, and I'll build the model for you. The problem with that is that there's always going to be dangerous things that can happen. And I don't know if you're planning to touch into that later, but one important thing is fairness in modeling. I mean, this is a hot topic right now, right? There is always should be there that is responsible for what this model is doing. There is no data science, nobody is responsible for. So one of the things is we've seen in the press and in different places where all these models are coming and are being homophobic or racist, and then we are taking the approach of saying, that was the model. That wasn't the model, that was the responsibility should be the people who build the model, right? We don't want to have a dystopic view of the future, like for example, in Terminator, like Skynet, where they take over, that was Skynet who did it. And so, no, we have to take responsibility, and we have to be aware of what we build. So if there is not a data scientist, who can be accountable for building that model, right?
Troy, did you want to add anything?
I agree. It gets hard. You're hearing the term citizen data scientist now and stuff like that. Ultimately, somebody needs to be responsible. You could go out and get a consultant or something like that to help you, but there needs to be some level of involvement and some level of knowledge brought to the process.
Saad, do you think you can do it without a data scientist?
No, I think the key area here is really going to be when we start relying on deep learning in these networks, and the data is really critical, but the data is critical if it represents everything that the system is going to see. So it has to be unbiased, and I think that's where the data science need to inject that this really is an unbiased sample and the model is really trained. Because if you don't do that, you can get into bunny holes and then come up with answers that are wrong.
As we close today, I want to give you an opportunity. You've heard each other's presentations, you've heard each other's answers. If you have one thing that maybe didn't get touched on that you think is really, really important about demonstrating a business case for AI, what would that be? Glenn, if you want to start.
Well, I think I agree with the fellow panelists have said. I think connecting the value of the model that you're going to build, because a lot of these things can be really cool, and having a clear, for example, for me as a researcher in machine learning, I have all the time to have a cable to Earth, so I don't fly into blue sky and do stuff that nobody cares about. So being able to connect that research to actual value from the business is very important to me. So I think that's something that everyone who is doing data science, because it's so cool and so exciting, we can get distracted for all the things that are going on and then not do things that provide value. So I think there has to be a good balance between exploration and value and providing value to the business. So.
Building on that, tie it to value, but start small and then iterate. Fail fast, but get started and get going. But don't try and do the whole thing all at once, because through refinement, it's going to be a better process.
I agree both, and the only other thing that I would add is to be able to share the findings and the failures, so that there are other instances where the same kind of things that you're doing can actually have an impact in other areas in the business. And that's one of the things that it can't just work in kind of like a black box. So you need to be able to share and communicate that.
I appreciate that. Saad also is one of the members on our Chartering Council, and we've had a lot of conversations about this space and what companies are willing to share. And I think one of the things that we're really trying to do is make sure that we can share knowledge to lift everyone else up in the region and their ability to apply AI in a reasonable way, so that we're creating business value, not just for a single company, but for the region as a whole. And so that's one thing that we have run into, that we have a difficulty in having companies share, because they're just sort of getting started. And we really appreciate those companies that are a little bit further in their journey that can share those experiences with others. One of the things that we've talked a lot about with the Chartering Council is creating a community of practice at MSOE around the application of AI, machine learning, deep learning, and related technologies. And so for those of you in the room that registered for today, we hope that you'll be part of that community of practice as we go forward. We're going to wrap up this panel. The reason we didn't do questions from the audience is just for efficiency's sake. We took those questions in advance, and all of the questions that were asked today were asked by our audience members. If you have any additional questions, I'm sure that they'd be happy to answer them afterwards, but we're going to transition to the second panel, which will start at 2:10. So let's give a round of applause for all of our panelists.